Find the absolute value of the complex number. Round your answer to 2 decimal places if necessary. This can also be called the modulus of the complex number. So essentially we are trying to find the modulus of -3 plus 5i. And this is just the square root of the sum of the squares. So that would be -3 and 5. So we get this is square root of 9 plus 25, which is the square root of 34. And they asked us to go for decimal places, so we go then to our calculator and go to 2 decimal places, and we get 5.83. So what this represents is the distance from the origin in the complex plane to the end of the number -3, 5. In other words, -3, 5, that distance right there. That's the modulus of this complex number, or the absolute value of the complex number, is the distance, the length from the origin to that number. Find the absolute value of the complex number -7. Now, -7 is actually -7 plus 0i. And the absolute value of that number is just the square root of the sum of the squares. So we have -7 squared plus 0 squared. We get the square root of 49, which is 7. Now what this represents is the complex number -7 is left on the real axis, and the absolute value of the complex number -7 is the distance from the origin to that point. Distance is always measured positive, so we get the distance of 7. So the absolute value, or the modulus, of the complex number -7 is 7. Write the complex number in trigonometric form using degree measure for the argument. So we have -3i. So a quick sketch shows us -3i is on the imaginary axis, and it's down 3. Now the trigonometric form is going to be r cis theta. Some books use this notation, or r times cosine theta plus I sine theta. Now the theta would represent this angle, and so we could possibly have 270 degrees, or other books you cannot have any principal argument larger than 180, so then you would have to go backwards this direction and have -90 degrees. Now this depends on how your book defines the principal argument for a trigonometric number, a complex number in trigonometric form. Now the r is the modulus of the complex number, or the absolute value of the complex number. In this case, it's this distance, it's 3. So we can see r equals 3. And theta equals, could be 270 degrees, or could be -90 degrees, and that depends on how your book has defined this. So then we would write it 3 cosine of 270 degrees plus I sine of 270 degrees, or 3 cis -90 degrees. These are the 2 common books that I have used. These are the 2 different notations. Write the complex number 6 plus 8i in trigonometric form using decimal degrees and 2 decimal places for the argument. So let's look at where this is. Over 6, up 8. This is the complex number they're talking about. And r, this is the modulus, or the absolute value. We need to find that distance, and we need to find that angle. We can do that with our basic formulas. R equals the square root of a squared plus b squared. In this case, A is 6, so 6 squared, plus and B is 8, so 8 squared. So we have 36 plus 64, that is square root 100, so we get R is 10. So that's the modulus, or the absolute value. Now we can also work out tangent theta equals B over A. So tangent theta would be, and you could also think of this in terms of that being 8 and that being 6. Regular tangent is opposite over adjacent, SOHCAHTOA, TOA, 8 over 6. This gives us theta. And we go to our calculator, make sure you are in degree mode, and you do arctangent of 8 divided by 6. You could also reduce that to 4 divided by 3 if you'd rather. 53.130. And I've already forgotten the instructions, so I'm going to go double check. On the last problem, I believe it was to the nearest tenth. So let's go to the nearest tenth. Okay, so R times cosine theta plus I sine theta. That form would be 10 times cosine of 53.1 degrees plus I sine 53.1 degrees. You might also have the formula that you're using, 10 CIS, 53.1 degrees. CIS stands for cosine plus I sine. That's just all of this extra. This is just a shorthand notation. So we have now found the trigonometric form for this complex number. Write the complex number in the form a plus bi, or standard form. In order to do this, we need to just simply evaluate cosine 315 degrees and sine 315 degrees, and then distribute the square root 6, and that should be it. So 315 degrees, that's reference angle 45 degrees, and quadrant 4. So all students take calculus. We're in quadrant 4. So cosine will be positive and sine will be negative. All right, let's now compute this. We have square root of 6 times. What's cosine of 45 degrees? Square root of 2 over 2, and it's positive. Plus I times sine of 45 degrees, but negative is negative square root of 2 over 2. So although this is stuff we've done a lot in the past, just as a reminder, when you have an angle that's not in the first quadrant, you get the reference angle, assuming it's a nice unit circle reference angle, and then the quadrant. The reference angle gives you the value, like square root of 2 over 2, and the quadrant gives you which one is positive and negative. Now we distribute the square root of 6, and we have the square root of 6 times 2 over 2 plus I times the negative square root of 6 times 2 over 2. We can reduce the square root of 12. This is 2 square root of 3 over 2. Let's change this to minus now. I times, same thing, 2 square root of 3 minus 2 over 2, sorry. And the 2's cancel, giving us our final answer, square root of 3 minus square root of 3i. That is our complex number in the standard form. Write the complex number that's in polar form, or trigonometric form, in standard form, a plus bi. So right now what we know is this is modulus, or absolute value, 3, and the angle is pi thirds. So the location of this one would be pi thirds out 3. So it's this number. So I can see that the x value will be positive and the y value will be positive, but really all we have to do is evaluate these values, sine and cosine of pi thirds, and see what we get. So when we evaluate these, we get 3 times cosine of pi thirds is 1/2, plus I times sine of pi thirds is square root of 3 over 2. We now distribute the 3, and we get 3/2 plus 3 square root of 3/2 I. And that is all there is to getting to standard form from trigonometric or polar form for complex numbers. Perform the indicated operation. In this problem, the indicated operation is multiplication. Write the answer in the form a plus bi. So although they give us trigonometric form for the complex numbers, and you see the i's, you know these are complex numbers, they want it in standard form when we're done. However, multiplying in trigonometric form is very simple. The rule is you take the modulus, or the absolute value, the 4, times the 6, and then you take the angles, 135, and you add those in the 225, and then plus I sine, and this, again the same sum, 135 degrees plus 225 degrees. So this is how you do multiplication in trigonometric form. The r's of the complex numbers multiply together, and the angles multiply together, but you still have r cosine plus I sine. So we have, for this problem, 24 times cosine 360 degrees. When we add 135 and 225, we get 360 degrees, plus I sine 360 degrees. Now, this is the answer, but it's not in the correct form. They want us in a plus bi, or standard form. So we have to evaluate the cosine 360 and the sine 360. Cosine of 360 degrees is 1 plus I times, and sine of 360 degrees is 0. So we have 24 times 1, or just 24. And some books will expect you to write the plus 0i for standard form, or just the 24. That'll depend on your teacher in your book. This is how you find the form a plus bi with the multiplication of trigonometric numbers. Trigonometric form of complex numbers. Perform the indicated operation. In this case, the indicated operation is division, and we want to write our answer in standard form a plus bi. Now, when we are doing division of complex numbers, notice the i's, in trigonometric form, the division, you just divide the moduli, or the 5 and the 4, and you subtract the angles. So the one on top is 200 degrees, minus the one on bottom is 50 degrees. And then that's the new angle. So cosine of that plus I sine of the same number, 200 degrees, minus 50 degrees. So we have 5/4 times cosine of 150 degrees plus I sine of 150 degrees. Now this is great, except for we're in the wrong form. They want us in the a plus bi form. So to get a plus bi form, we just evaluate. We'll find cosine of 150 degrees and sine of 150 degrees. And we'll get 5/4 times. Cosine of 150 is negative square root of 3 over 2. The reference angle is 30 degrees. Cosine of 30 degrees is square root of 3 over 2. And the quadrant is in quadrant 2, and cosine is negative. Plus I sine of 150. That second quadrant, 30 degrees, sine is 1/2. So we now distribute the 5/4, and we get negative 5 square root of 3 over 8. So that would be this, plus 5 over 8i, and that would be this. And that, I didn't mean to cross out my negative sign. That is our answer. Okay, great.